Hello guys, we are going to continue a discussion with respect to statistics, and in this video we are going to discuss about standard normal distribution. Already in our previous video we have discussed about normal distribution or Gaussian distribution. In this standard normal distribution we are also going to discuss about a very important formula which is called as z-score. Now with the help of z-score it will help us to identify that any value, like how much standard deviation it is away from the mean, right? I will just show you the entire formula, the working, everything as such. But first of all, let's understand what exactly is standard normal distribution. Now let's consider a random variable x, okay? It has some values 1, 2, 3, 4, 5. And let's consider this is following a normal distribution, okay? And probably if you compute the mean will be 3. And the standard deviation will be somewhere around 1.414, okay? So if you go ahead and compute it, like 1 plus 2 plus 3 plus 4 plus 5 divided by 5 is nothing but 3. And the standard deviation is somewhere around 1.414 when you probably apply the variance and standard deviation formula. Now, one very important thing is that I will just, to make my calculation easier, let's consider this to be approximately equal to 1, okay? So I'm just saying that let's consider the standard deviation for this distribution is 1, okay? Something like this. Why I'm doing it? Just to make my calculation easier, okay? Now let's consider this is the entire Gaussian or normal distributed. So in short, if I probably draw my Gaussian or my bell curve, it will look something like this, okay? Now this is my bell curve. You know the mean element is 3, right? If you go one position to the right, since I've considered standard deviation as 1, so the next element will be 4, then this will be 5, then this will be 6. Similarly, here you have 2, 1 and 0, okay? So this is a normal distribution curve. Now let's say that this is my random variable, right? So over here, again, I'm going to write my random variable 1, 2, 3, 4, 5. Now, whenever I have this kind of distribution, and let's say I want to convert this distribution in a way wherein my mean is equal to 0 and standard deviation equal to 1. Understand, in Gaussian distribution, we can have any standard deviation, okay? We can have any mean. But if we take this distribution and try to apply a transformation technique wherein after we convert or after we change this random variable to something wherein I will be getting my mean is equal to 0 and standard deviation is equal to 1, then those kind of distribution we will specifically stay as standard normal distribution. Again, I'm going to repeat it for you guys. Let's say that I'm having a Gaussian distribution with some mean and standard deviation, and I want to convert this distribution into a different distribution wherein I get a mean is equal to 0 and standard deviation equal to 1, then we specifically say it as standard normal distribution. Now the question rises, how do we convert this? This, for converting it, right, we will specifically use a formula called as z-score. Now the z-score formula looks something like this: x of I minus mean divided by standard deviation, okay? So by using this technique, we will be getting another random variable y, which will be how much? Let's see, okay? So if I apply for every of this value, this particular formula, let's say for 1, I will go ahead and apply. So it will be 1 minus 2, okay? 1 minus 3, because my mean is 3, right? So here you have 1 minus 3 divided by standard deviation is 1. So I'm going to get minus 2. So this 1 will get changed to minus 2. Okay. Then coming to the second one, 2 minus 3 divided by 1. Right. So it will be nothing but minus 1. So this 2 is getting converted to minus 1. Okay. And similarly for the third one, here you can basically see 3 minus 3 divided by 1. So this is getting converted to 0. So now see, initially the mean was 3. Now this is getting converted to 0. Now are we getting the mean is equal to 0 by converting this entire distribution with this formula of z-score? Yes, obviously we are getting it, right? So it is minus 2 minus 1 minus 0, right? Then let's go to the next step over here. In the fourth, what about the fourth element? 4 minus 3 by 1 is nothing but 1. So here I'm going to get 1. And if you do the same thing for 5, you're basically getting 2. So in short, for this distribution, when I applied the z-score, I got the outcome of another random variable where I have these values. Now this will be again, this distribution will again be looking like this. But here your mean will be 0. Then one step to the standard deviation, you will be getting 1, then 2, then 3, then 4, like this. And similarly over here, you'll be having -1, -2, -3, -4. So what has exactly happened? We have converted one distribution, a normal distribution, to a standard normal distribution. Whenever we say a random variable belongs to a standard normal distribution, it basically says that its mean is 0 and standard deviation is 1. Okay. Now, why it will be super important, I'll just let you know in some time. Okay. Just in this specific video itself. But again, let me write the notation over here. A random variable belongs to a standard normal distribution if its mean is equal to 0 and standard deviation equal to 1, right? So any distribution, right, it basically belongs to a standard normal distribution, that it basically says that its mean will obviously be 0 and standard deviation equal to obviously 1. Now, why will this z-score be super important? Okay, why this z-score will be super important? Let me give you a very good example with respect to z-score. Let's say that I have a specific question. Okay, I have a curve. Okay, over here. Let's say my mean is 4. Okay, and my standard deviation is 1. Okay, let's say that I have this. My mean is 4 and standard deviation is equal to 1. So initially, what I'll have 4 over here, then 5, then 6, then 7. Okay, then similarly, I'll have 3, 2, 1. Okay, now in this particular question, let's say this is my curve. Now in this question, if I say how much is 4.25, okay, or I have a question over here. So my question is, how many standard deviation 4.25 is away from the mean, So if this is a specific question that I get, so where does 4.25 fall? So if this is my mean and this is 5, so 4.25 will fall somewhere here, right? Somewhere here. So how do I find out like how many standard deviation away, like 4.25 is away from the mean, that is 4. Okay. Now in this case, here my x of I is nothing but 4.25. Okay, my x of I is 4.25. Now, if I go ahead and apply my z-score formula, so what will happen? 4.25 minus whatever mean is there. What is the mean? 4 divided by the standard deviation, that is 1. So here I'm getting 0.25. Now, this basically indicates that 4.25 is somewhere 0.25 away from the mean. Okay, something like this. So this is the area that you will probably be getting. In the future video, we'll also try to understand how to calculate this area. Okay, there is a generic table that is given for Z table where you can also find the area under the curve, like how much area is probably present between 4 to 4.25. This kind of area also we can probably understand and we can find out. Okay, if many people are maybe thinking, Krish, what kind of practical application it will come? Don't worry, I will explain that as we go ahead. When I give you those interview kind of questions and where I explain you like how this area will be coming, it will be super important for a data analyst, for doing exploratory data analyst, for understanding about that specific data. But one question that I specifically asked over here is that how many standard deviation is 4.25 away from the mean, right? So this is a very good question. Now similarly, if I say how much standard deviation 2.5 is away from the mean, then I will probably replace 4.25 by 2.5 minus 4 divided by 1. Then I will probably get minus 1.5. That basically says minus 1.5 away from the mean. And since it is in a negative direction, I'll be getting over here, right? So let's say if I take my x of I variable as 2.5. Now what will be my z-score? My z-score will be nothing but 2.5 minus 4 divided by 1. So in this case, it will be minus 1.5. Right? Now, when I say 1.5 deviation, minus 1.5 deviation, it is somewhere here, right? And we can probably take that, we can probably conclude that this 2.5 is 1.5 standard deviation away from the mean on the left-hand side. Okay. Now, you may be thinking, Krish, why do we use this z-score and all? What form? Why we are specifically using standard normal distribution and all? Here also, I'll give you an example. Let's consider a specific data set. Okay. Now in this data set, let's say that I have a variable which is called as age. I have a feature which is called as age. I have a feature which is called as weight. I have a feature which is called as height. I have a feature which is called as salary, right? Now, when I have all these features, let's say my age, I'm having some values like 24, 25, 26, 27, 30, 31. Okay. Let's say weight, I have like 70, 60, 55, 40, 30, 25, right? And height, I have like 175, 160 centimeters, 150, 130, 175, 180. Okay. And then salary, let's say I have 40K, 50K, 60K, 30K, or 20K, and let's say 70K. Okay. Now here in all these features, understand one thing. Units will definitely be different. Age is how do we compute? In the form of years. Weight we compute in the form of kgs. Height we compute in the form of centimeters. Salary we can probably use a unit as INR or dollar. Now whenever this kind of units are there, understand, whenever you solve a machine learning problem statement, whenever you create a machine learning models, the first rule is that we try to bring all these features in a same unit scale. Okay. Now, in order to bring in the same unit scale, because see, if I probably take all these values and try to plot, right? Let's say if I'm plotting age and weight, right? If I plot age and weight with this big values, my data point will be scattered here and there, right? Like this, my data point will be scattered somewhere here and there, right? This kind of scenarios may happen, right? So what we do is that we really need to bring this in the same unit. Now, if we are able to bring in the same unit, there are many algorithms like clustering algorithms, linear regression, and all this kind of models, right, require all the values to be in the same unit, so that the machine learning models will be able to optimize themselves in a better way. It will be able to give a better performance, right? Remember these things. So what we do is that we probably convert all these features by a technique which is called as standardization. Okay, standardization. Now, whenever we say standardization, it is basically applying a Z-score formula on every feature. So for this particular feature, we specifically apply a Z-score formula, right? We probably calculate the mean of the age. So here it will be x of I with mu of age, right, divided by standard deviation. For this, when I'm computing, then it will be x of I minus mean of weight, right, divided by standard deviation. Similarly, for the third, it will be mean of height, and for the fourth, it will be mean of salary, right? So what we do is that we apply Z-score on this entire feature, and once we do this, we specifically get all the values based on the distribution, and we try to bring down this in the scale unit, right? So most of the values will be ranging between -3 to +3, right? All these values, see, once we convert this, right, all with respect to the standard normal distribution, you'll be able to see most of the values will be falling between -3 to +3. So all will get converted into the same unit, and we will get all these values between -3 to +3, right? It can be more than 3 if there is a specific outliers also, right? So by this, we are able to bring efficiency in the model. We are able to bring the performance of the model in a better way, right? So this is with respect to a specific data set, and this process is called as standardization. Later on, when we will be doing exploratory data analysis and feature engineering, creating ML models, we will be using standardization process. There is also a process which is called as normalization, which we'll probably discuss in the future lessons. But I hope you got an idea where specifically Z-score is getting used. Like whenever we have any feature, some of the algorithms, like what all algorithms they will be, like they are like clustering algorithms, because in clustering algorithm, we try to find out the distance, right? And once we bring into the same unit, all the distance will be near. So the calculation will actually happen fast, right? The algorithms like linear regression, right, we specifically do standardization. The algorithms like logistic regression. So these all algorithms we'll learn in the future in depth, but there are definitely many algorithms where we specifically apply this kind of standardization.